Hello everyone. We're going to start on a topic that will be very important to us because if anything that we do in derivative calculus is to be applied, then we really have to have a few things established, such as where do we find maximums and minimums of functions. This is important because we're going to be looking for places where functions may be defined and help us find optimal solutions, for example. Well, if it is to do anything at all, we're going to have to start from the basics. And one of those basic ones is defining what we mean by extrema, that is, maximum and minimum points on an interval. And we give this definition here that says if we have a function f of x and it's defined over an interval from between two numbers on the x-axis, from x equals a to x equals b, and there's a point C between point A and B such that we meet a few conditions, we can call it a maximum or minimum. The first one is we call it a minimum if the value of f of c is less than or equal to f of x for all x in that interval from a to b. And f of c is a maximum on that closed interval from a to b if f of c is greater than or equal to f of x for all x in the interval from a to b. So I've drawn a function right here to help illustrate that point. Now let's just consider the points right here. Here's our interval. We're going from x equals 1, we'll call that a, to x equals 8, and then we'll call that b. So what can we say about our extrema? Well, certainly at x equals 3, you can see, or thereabouts anyways, we're going to need some good methods to find those points. Derivatives. So we're going to have to find that point. We find that right here at this point, x equals 3, it looks as though the value of f of x is greater than all the values of x anywhere else. We call that an absolute maximum. So where there's an absolute maximum that occurs at x equals 3. When we identify where a maximum or minimum occurs, we're identifying an x value where it occurs. How about a minimum? Well, certainly we can see that there's an absolute minimum right about near 7 over here. It might be at 7, might be to the left of 7. We'd have to find out by doing some derivative work again. But at x equals 7, it looks like we might actually have what we'd call an absolute minimum. So at x equals 7. Now, relative maximum, absolute maximum, and absolute minimum, you can see why we call them absolute maximums and minimums, because they are greater than or less than all the other values around them. So we would do that. But we also define points called relative maximums and relative minimums. In this particular function, we would normally say that it looks like this value right here at a is less than the other values that are near it, but because it's an endpoint, we're not going to really define it this way. So there's two other types of minimum, extrema, that we're going to also define as we go along in this discussion. So let's do another one right here. Let's consider this function x squared minus 4x on the interval from 0 to 4. Where do the relative maximums and minimums occur? Well, one of the things that we should do, putting all of this in context, is that f prime of x needs to be found. We need to find the derivative. And I'll explain why here in a minute. But let's find the derivative. Our derivative of f of x equals x squared minus 4x. We know it's simply 2x minus 4. And we'll note that we get a horizontal tangent line, that is, a place where the derivative is equal to 0 at the point where 2x minus 4 is equal to 0. Well, if we work that out, of course, we know what happens. That's at x equals 2. So what's special about at x equals 2? Well, let's go to the graph. Here's the graph of y equals x squared minus 4x, and if we look over this closed interval from 0 to 4 right here, so let's go ahead and close our interval so we're not looking at anything beyond these endpoints right here. We're just interested in what happens. We see that, oh, at x equals 2, the derivative is equal to 0. So we might ask, well, is that the only kind of place where we can find a maximum or minimum if the derivative is equal to 0? Well, it is a place, but it turns out that there are other places as well. And we're going to talk about those in a minute.